Today, inscribed angles. So if I'm talking an inscribed angle right here, that's where an angle has its vertex on the circle. So see how E is on it? Yesterday, we dealt with all of them coming out of the center. The center ones are equal, not the inscribed ones. So the inscribed ones has the dot on the circle. So that vertex is on the circle, not in the middle of the circle. That's the difference from today and yesterday. So the rest of the formula, what it's saying is the sides will make an arc. So in other words, if you were to draw this angle, this is where it starts, here's my angle, and here's where it ends. Well, that's going to be the starting and ending point of the arc that we're talking about. So if angle E is something like 40 degrees, what's going to happen is the arc is going to be double. So yesterday when it came out of the center, they were exactly the same. They were equal. When it's inscribed, so when it's on the circle, it's going to be double. So it's going to be twice as much for that. Okay, so now what we're going to do, the first one's kind of more vocabulary. And then, I mean, that's the only thing I'm showing you today. Everything else is just example problems. So this says name the intercepted arc for RTS. So if you highlight R, T, and S, they just want you to know the arc. So this is super intro problem. You're not going to see things easy like this. But I just want to show you that it makes that arc right there. So we're talking arc RS. That's all they want. And then to go the other way, the other direction, he wants to know the inscribed angle that intercepts arc SV. So if I'm talking arc, if it's arc, it's the curve. So we're talking here to here. They want to know what angle goes with that. So you're starting here, so you just follow the line that goes with it. You're trying to make the angle that basically is eating the arc, if you will. So here's your little alligator that we used to talk about back in the day, gobble, gobble, eating the arc. All right, so that's all you have to do. Your starting and ending point is going to be your starting and ending point for your angles. So that's really important for that. When we're talking about the angle, we're talking about angle VRS. So whatever this is, let's say this angle right here was 120, or this arc was 120 degrees, then the angle would be 60. Okay, so you have to, it's always half. So let's get to some problems that you're going to see. It says, what is the measure of each numbered angle? So I'm looking for angle 1. So in this case, I'm going to highlight angle 1. Here's my starting point and my ending point. So they want to know that. Now, if I look at the arc, that is a half a circle. This is a semicircle. So we learned before a semicircle is 180 degrees. So if this is 180 degrees, you cut it in half to get the angle 1. So 180 divided by 2 is going to give me 90 degrees for angle 1. Okay, so that's all they're talking about. If they asked you to find, let's say we had angle 2 in there. If this part right here is 40, then angle 2 in there would have been 20. Okay, and then another thing. So this problem had extra numbers because it might have asked you for extra angles. So let's say angle 3 in here we're looking for. So if I'm looking at angle 3, that's going to make that 70-degree arc. So if you cut the 70 in half, you're going to get 35 right there. Okay, if you add these up, 20 and 35 gives you 55, and that makes this angle. So 55 doubled is 110, which is the same thing as 70 and 40. They already gave you that anyway. So I'm just trying to kind of give you a whole bunch of different examples, not to overload you, but just to give you a bunch of examples to get a light bulb. All right, so part B. Over here, they only want angle 2. So if they want angle 2, we're looking at this right here. So what I'm trying to find is I'm trying to find this arc. So to be able to find that arc, if you notice that that green arc is the same arc that belongs to this angle. So the 70 degrees, that is just in your way. That is just extra information. You don't need it. So if this inscribed angle is 38, that makes this arc up here double that. So 38 times 2 is 76. And that belongs with the 2 as well. So you can either just realize that if the two angles share the exact arc, they're going to be equal to each other. Or you can figure out that that's 76, cut it in half, and get 38. Either way. Okay, next. And an angle is not inscribed like this angle right here. This is not an inscribed angle because the corner is not on the circle. That goes for all those angles in there. So it's only, all this stuff only works is if the corner is on the circle. The last part of the notes, there is one more part. This part of the notes is opposite angles in an inscribed quadrilateral. So when you see this word inscribed, this is an upper level kind of thing. You'll see these things on SATs and ACTs. So you need to know what inscribed means. That means it's inside the circle and all the corners touch. So this would be an inscribed quadrilateral. Every single corner touches the circle. That's what makes it inscribed. And it's saying the opposite ones are supplementary. So that just means the measure of angle A and C, they add up to 180. And the measure of B and D also add up to 180. So that's just one of those postulates, one of those things you need to know. So examples that go along with it, opposites, if it's inscribed, see X, Y, Z, W, X, Y, and Z are all touching the circle, so it's inscribed. Opposites add up to 180, so Y is 60, 180 minus 120. And 180 minus 55 is going to be 125. Oh, I'm going to double check in my head. Yes. No, yes. Sorry. So that's all you have to do for that one. Over here, same idea. This opposite, the measure of angle 1, is going to be 88, because 180 minus 92 is going to give you 88 degrees. Then I'm missing the other two. So when you're missing the other two, notice you have parallel lines. So you have parallel lines and a transversal. All that stuff just keeps coming back. So parallel lines and a transversal. These are same side interior angles, which means they are going to add up to 180. So in this case, these ones also add up to 180, but only because you have parallel lines. So that means the measure of angle 2 is 92 degrees. Okay, that'll only happen if you have those parallel lines there. Down here, this one, you can kind of see this kite that's in here. Okay, so this is 65 right there. And this is perpendicular, which is going to cut that in half to be another 65. So if you get the entire angle, that's going to give you 130. So that's the 130 angle is this one right here. The reason why I'm doing that is because you still have an inscribed quadrilateral. So this is my inscribed quadrilateral. It is a kite. Okay, then what's going to happen is if this is 130, 180 minus 130 is going to give you 50. So I know this whole thing's 50. And just like this, we learned the kites that this will be cutting it in half. So each one of these is 25 degrees. We're just cutting the 50 in half. Okay. Over here, number 5, it's a little more difficult because they're asking for side lengths. When there's no segment above it, that means the length of AB. So they're asking you for this right here, and they're also asking you for the entire diameter, AC. Okay, notice they gave you a 30, that if this is 90, that is 90, which means this is a 30, 60, 90. So this is more old stuff we're bringing in. So if you remember that we did Z, we did 2Z, and across from the 60 was Z square root of 3. Okay, so if you're doing it that way, and you divide by 2, this is your Z value. So that's going to be this part right here. This RB would be 3 divided by 2 square root of 3. I should have made it a little bigger, shouldn't I? So instead of Z, I'm going to put that in there. So I've got 3 square root of 3 over 2, because we're still going to have to do a little more work to get this X over here, this X value. Now this one down here, I'm going to have to times that by the square root of 3. Okay, remember when you're multiplying, you don't do the top and the bottom because this is really square root of 3 over 1. So the bottom doesn't really change. Square root of 3 times the square root of 3 is 3, and then 3 times 3 is 9. So this piece right here is 9/2. Okay, so we've got 9/2, and then we're also going to have to figure out this piece right here to add it to it. So 9/2 is from R to C. We're going to use that in a minute. So this is a more challenging problem. So now over here, I've got this X, I've got this missing piece right here, and I also have that if these are 30, that makes a total right here of 60. 180 minus 60 is 120 for this whole thing. So again, I've got a 30, 60, 90. So this right here is your Z square root of 3 because it's across from the 60. So if I divide out, if I divide by the square root of 3, then that's just going to get rid of the square roots of 3. So your Z value right here is just going to be 3/2. And then if I do 2 times that up here, that's going to give me 6/2 or just 3. So AB is 3. I know that was super confusing. If you don't understand what I'm saying, let me do this again because it sounded. So what we had from the other problem was this was 3 square root of 3 over 2. And then across from your 30 was just Z. So this is Z square root of 3. And then this is 2Z. And the 2Z is the one that we're actually looking for. So I just wanted to blow it up so you can actually see. When I'm going to divide by the square root of 3, since this is in the denominator and this is in the numerator, they're just going to cross out. So that's how I got Z is 3/2. So this is 3/2. This part right here, we just times it by 2, give me 6/2. So that's where the 3 came from. So I have 3 over 2 here, and I've got 9 over 2 from the green part that we did up here. So if we add that, that's going to give me 12 over 2, or 6. That's one of the more challenging ones. Okay, down here, find the measure of 1 and 2. The easiest way to do that is if you notice that 2 makes a semicircle. So it connects the corners of a diameter, which means the arc is 180. And since it's inscribed, you cut 180 in half to get 90 degrees. And then if you look at angle 1, I think the easiest thing to do, because if that's 90, this is 90. So if I just have a triangle and subtract 180, I can do 180 minus 90 minus 40. And that's going to give me 50 degrees for that one. Okay, over here, I'm looking for the A. So if you, ooh, that's bad. So if you use this angle, which makes the arc A, then you can see that it's inscribed and we're just doubling 60. Okay, next I can do B. So if I look at B, B goes from here to here. So I need this entire piece from here to here. So that arc, I just found that part A was 120 and this part right here is 30. So that green arc that I just made is 150. If I want the inscribed angle that goes with it, I cut that 150 in half, which is going to give me 75 degrees. Okay, a couple more random ones. So it asks you the measure of angle A. Again, I need you to pay attention to see if it's a semicircle. If it's a semicircle, that's 180 degrees. Cut it in half for the inscribed angle, which is 90. All right, over here, you've got all of these the full way around. If I want the measure of angle A, notice that A makes the 90 and the 100. So the arc, if you add those up, you get 190. And if you cut 190 in half, that's going to give you the measure of angle A. So that's going to give you 95 degrees. So that's kind of similar to what you're going to be doing for the rest of these in this problem. If you're looking for B, B is right here, so you're going to add 64 and 90, which is going to give you 154. Cut it in half to get your inscribed angle. So that is going to give you 77. Yes, 77 degrees for the measure of angle B. Okay, similarly with C, you would do the 106 and the 64, cut it in half. And then D, you would do the 106 and the 100 and cut it in half. Okay, I do have that reminder in blue real big that a full circle is 360 degrees. So that will definitely help you on that extra credit. You will 100% need to know that on the extra credit worksheet and probably for quizzes and tests as well. So in that last problem, all of those numbers, if you add them all up right here, they should give you 360. So if they leave one out, you can just subtract the other ones from 360 to get that one. All right, down here, I'm looking for all 4 angles. Okay, now if you notice that angle 4 makes the 60 and the 80. 60 and 80 equal 140. If you cut it in half, that's going to give you the measure of angle 4. Okay, and then opposites. This is an inscribed quadrilateral. So if I just do 180 minus the 70, because they're going to be supplementary, that's going to give me the measure of angle 2. Okay, that's an equal sign. All right, next, These two, they don't really give us anything. I've got one right here, and all I've got is the 80. I don't have the other one. But if you notice, one connects the diameters. So that's going to be 180 degrees, and then cut it in half to get angle 1, which is 90. Okay, and if they asked you to find this one, since we know that from here to here is 180, you would subtract the 80 and just get this arc, which is 100. Those are the kind of things you're going to have to do to figure out pieces that are missing. And then again, for opposites, they are supplementary. So 180 minus 90 is going to give you 90. Or you could have seen that angle 3 also has, makes a diameter. So angle 3 is also 90 degrees. And if you're trying to find this piece right here, we know that this is 180. So 180 minus 60, this is half a circle, 180 minus 60 would have given you this red one, which is 120. Some of those things you'll have to find later. Okay, last one. So it's just if it looks all crazy like this, this is still inscribed. Okay, this is still an inscribed angle right here because the vertex is on the circle and the end is still touching the circle. So it says is tangent to the circle if PMQ, so if I'm doing PMQ, that's this arc here, a really bad one. But if that's 212, they want to know what PQ angle PQR is. So they are wanting you to find this angle. Okay, so that means I'm going to need this arc. That's the arc that it's connected to. So I need the full circle. This is most of it, and that's the 212. So full circle is 360. If I subtract the 212, I'm going to get 148. Yes. So this is 148 degrees. If I want the inscribed angle, I cut that in half, and that's going to give me a decimal. But unless I added wrong, no, that's right, 360. So that's going to give me 71 point something. Okay, I'm just cutting the 148 in half because that's the arc that belongs to that angle right there. Okay, so I will attach extra credit. You'll see the difference. One will say the homework number 2, and one will say the worksheet. The IXLs, they were easy. I think they were a little too easy, but if you want extra practice, IXL U11 is pretty general for these problems. So good luck, and don't forget about working on your weekly. Oh, wait a minute. I forgot about these. Okay, so one more thing. Sorry, it's really long today. So I wanted to add on to this. This is what we had on there yesterday. So we added a little bit yesterday, and then today I wanted to add just a couple of things to help us along. So today what we learned were you're going to have to go to the angles. So do the angles with the central angle, and then right here, these are going to be our inscribed angles that we just talked about today. So add this one to your worksheet. That's an N. Okay, so all we learned today is if you do something along these lines like this, and you give yourself an X, then we want to know that the arc is double that. So that's the most important thing. And then the other thing, it can just look differently. So it's not the same, but it was like that last problem. So if you have something along these lines like this and like this, if your angle is X, your arc is still 2X. So it's just two different ways inscribed angles are going to look. Most of the time, you're going to get that one right there. And that's the only thing to add today. So we didn't have any others to add today, but we will add as we go along daily. Okay, have a good day.